What up? All right. In this is our last video talking specifically about factoring. Factoring will come up in future videos, but this is the last one that is like specifically working only with factoring. So we're going to look at a couple of specific um, special situations that can arise where we have a new method of factoring that we haven't talked about yet. Before we get into that, let's kind of revisit the idea of factoring a trinomial. Okay, again, it's called a trinomial because it's got three terms: 4x squared, 12x, and minus 40. Um, you'll notice that both these examples have a 4 in front of the x squared, but we're going to factor them in different ways. And the reason we're going to factor them in different ways is because in the first example, that number 4 is actually a GCF of all three of these terms. Because that was weird. Because all three of these terms can be divided by 4, I'm going to go ahead and take 4 out of all three terms, essentially divide it from all three, and then write what I'm left with. So x squared plus 3x minus 10. And then what we've seen is if you are able to take that number out, that 4 out as a GCF, we are now able to try to factor x squared plus 3x minus 10 by simply, because we know it's x squared, I know it's got to be x multiplied by x. The GCF is out front. So all I have to do is fill in these two spaces. And what we said probably 2 or 3 lessons ago is that if you're able to get it down to just x squared by itself with no number in front, I need two values that multiply to negative 10, but add to positive 3. Okay, and those will simply be the numbers that go in the parentheses. So negative 10, but adds up to positive 3. You can poke around for a while, but it's going to be negative 2 and positive 5 are the winning combination. So x minus 2 and x plus 5 is the factored version of x squared plus 3x minus 10. And then we have our GCF of 4 out front. So this right here is our factored form or our factored version. Okay. So there's the factored version of the first example. Now in the second one, it's a little bit trickier because 4 is not a GCF. I can't take 4 out of all three terms, so then what we have to do is we got to go 4 multiplied by negative 6, right? We're doing what's called the AC method if that A value is not a GCF. So 4 times negative 6 is negative 24, which means I need two numbers that multiply to negative 24 but add up to positive 5. Still has to add up to the B value. Okay. Two numbers that multiply negative 24 but add up to positive 5 are going to be 8 and negative 3. Now remember what I do with that is I'm actually going to replace the middle term. Instead of putting plus 5x, I'm going to replace that middle term with plus 8x and minus 3x, which is still the same because 8 minus 3 is 5. I'm going to bring down the 4x squared. I'm going to bring down the minus 6. And now I've turned my 3-term trinomial into 4 terms. So now I can split it up and factor by grouping. So here I have 4x is my GCF of just the first 2 terms, right? If I'm looking just at the 2 terms before the red line, GCF is 4x, which leaves me with x plus 2. And then on the right side, negative 3x minus 6 has a GCF of 3. But because the first term is negative, I need to include the negative as part of the GCF. So this is negative 3 times x plus 2, which then gives me x plus 2, and the GCFs come together for x minus 3 as the other factor. Okay, so we factored both of these. They both have a 4 in front, but they're very different styles of factoring. The last thing that we're going to look at for factoring, the last method, is what happens if you only have 2 terms, but those 2 terms maybe don't have a GCF. And there's a special situation that can arise. So if you have a binomial, again, binomial just meaning 2 terms now. If you have a binomial and the 2 terms you recognize are both something squared. Okay, so like 9, 16, 25, they're numbers that are equal to another number squared. If you recognize both those things and there's a minus sign in between the two terms, then we have a fancy way to factor this, and it'll factor into a plus b times a minus b. Okay, where a is the first term, the square root of the first term, and b is the square root of the second term. This doesn't make a whole lot of sense to talk about in generalities, so let's just get right into it and show you an example of how this works. Okay, if I look at something like x squared minus 49, this is also x squared minus 7 squared, right? Because 7 times itself is 49. So in this case, this fits the mold of a squared minus b squared. Okay, because it fits a squared minus b squared, to factor this thing, I'm going to do a plus b, which would be x plus 7, times a minus b, which is x minus 7. Now we know, or we've seen, that you can simply check your work by just multiplying this out. So if I multiply this out, if I distribute this to check, I get x squared minus 7x plus 7x and minus 49. And then here, when I combine like terms, the negative 7x and the positive 7x cancel out. And so I'm left with just x squared minus 49. So if I have two terms, it has to be a subtraction, okay? It has to be a minus in between those two terms. But then I can write it using this, it's called difference of squares, but I can write it using this a plus b times a minus b, okay? So our final answer that we're looking for is this piece right here. Okay, again, two terms. If I recognize that I could write this as 2y squared, right? Because 2 times itself is 4, y times itself is y squared, minus 9 squared, because 9 times itself is 81. Then I can simply write or factor this as 2y plus 9 times 2y minus 9, and we're done. And the reason that we know this is going to work is because one's plus and one's minus. I get that cancellation that we had in the previous example. If you were to redistribute this, your two middle terms will cancel out, and you'd be left with just 4y squared minus 81. Finally, the last one here, again, 25 is 5 times itself, so 25z squared is 5z times itself. Now, right away, this method's not going to work because of that plus sign, okay? So because it is a plus, this thing cannot be factored. It only works if we have a squared minus b squared, okay? So go ahead, pause the video. I want you to try these two real quick, and then we're going to look at one more example with a GCF. So b squared minus 25, this is b times itself minus 5 times itself. So that means it'll factor to b plus 5 times b minus 5. Done there. Then over here, 9t squared minus 49. This is 3t times 3t minus 7 times 7. So my factors are 3t plus 7 and 3t minus 7. Okay, so two terms, subtraction sign in the middle, and you recognize that both terms can be square rooted or written as something squared. Now, we have been harping constantly. The first thing you want to do before you start factoring is you always want to look for a GCF. Okay, and the reason is this right here, it's got two terms, it has a subtraction sign in the middle, but I can't write the number 2 as something times itself. Also, the number 50 cannot be written as something times itself. But 2 is actually a GCF of these two terms. So if I do that, I have 2 times y squared minus 25, which I can write as y times itself minus 5 times itself. So then this would become y plus 5 times y minus 5 with that 2 on the outside. So if there's a GCF, you always want to take that out first. Make sure that that is your first step when you're looking at especially for these types of problems, because it's not going to work. You cannot factor uh, with the difference of squares if the numbers don't work out nicely. And again, for something like this, there is no number time. Well, there is a number times itself that equals 6, but it is going to be a decimal that we don't want to mess with. But -6 and 54 can both be divided by 6. So I'm going to take 6 out as a GCF. Because the first term is negative, I'm also going to include the negative with it. So I'm going to divide both those terms by -6. If I do that, I'd be left with x squared minus 9, which is beautiful because 9 is 3 times itself. 3 times 3. So this will be x plus 3 times x minus 3 in the parentheses with a -6 on the outside. Okay. So check for a GCF first, take that out, and then if you're left with 2 terms with a minus sign in between them, you might be able to use this difference of squares. That's the last thing for factoring. Ta-da, we're done. Yeah, and then we'll keep working with factoring and now starting to use it to solve some problems. But for now, we're good.